All right, welcome back everybody to Foundations of Programming. Yesterday we were working on the streaming guide and we got close to the very end, but we had an issue with the where to watch movie. So Thomas, talk to me. What exactly was the issue and what led to the fix?
So I just went back to the beginning, obviously not recoded everything, but I just followed the data all the way from the very beginning. Just double checked to make sure that we were getting movies into the catalog properly by pulling keys and printing those. And I was getting the keys to pull properly. So the issue had to stem from our where to watch method. And when I started breaking it down, I noticed that it was only returning one key. And that was primarily because on our else statement, we were just returning none. We were killing the iterator. We weren't allowing it to continue the iteration. So by removing return none and by replacing it with continue, it allowed for the iteration to keep going. And then the second issue that popped up right after was that we were trying to append both of these within the same statement, and append is only good for one um, input. We would have used extend, but I tried extend and that gave me a tuple. So instead, just use two append statements, and that gave me exactly what the output required. So then to wrap everything up, I just did a simple return statement with an if else to either return it if return the list if it had length to it, or just return none if it didn't.
Awesome. The append stuff. I remember you typing it out. I was like, there's no way like you can do that. And I don't know why I didn't say anything. I noticed you do it. I was like, he's putting two items, he's a pin in there. Oh, that's not gonna work. Extend should have worked. Did you put the item in an iterable when you tried to add it with extend? Because that's how extend works.
Yeah, when I put it with extend, it turned it into a tuple. So instead of returning it as a list like that, it would make little woman and the year. It put those in parentheses as like a tuple, like a single item tuple for some reason.
Hmm.
Um, so just to clean up the formatting for the output there, I just did two append statements. I mean, the output essentially data-wise was the same, but to iterate through it, like if I wanted to use this data later on, I would have had to remember, oh yeah, this first item is a tuple, not just, a list item.
Right. Yeah.
So,
Okay. That's weird. I wonder why you're giving you a tuple. But good stuff. Good stuff. All right. Okay. Well, thank you very much, Thomas. I appreciate it.
yep.
Let's go ahead and move on to today's topic of conversation, which is going to be um lesson 9. Lesson 9. I'm going to share now. Lesson 9, importing modules, exception handling, and unit testing. So, by the way, we're still in classes and objects, but we're going to add some other stuff to classes and objects as we progress through, right? So, everything we do will still be creating classes with it, and you'll see what I mean. But um, importing modules is just another addition to how we're going to be working with our Python files. We'll talk about exception handling, which will come in handy. It'll make those methods that you're creating a little bit more useful, and then we'll talk about unit testing at the end of it. Now, so what is a module? A module, you've already used it before, more than likely, but essentially it's just a Python file that you're able to import and use, right? It's a normal Python file that contains typically definitions of functions or classes that you would like to use in another file. Here we see a little code snippet for two ways of how this works. We have two files, right? We have the main.py and we have the mystats.py. Now, the main.py is the actual Python file that we're going to be trying to run, right? And the module file, right? The module in this image is the mystats.py. Notice that the mystats.py, it only has a definition of a function, right? They built this custom function called find mean that, as we can see here, should be able to take in an li, a list item, or I'm sorry, correction, not a list item, a list, which they're going to iterate through uh, and add to a variable called sum, and then return sum divided by the length of that list. Essentially, finding the mean of a list of numbers, right? They add the definition of this function into an individual file, which they're calling the module. Um, and then in the main file, the main.py, they're saying import my stats, right? Uh, this allowed them to use that MyStats module they created, right, and import it, and use the function that was within that module, find mean, to use it inside the main.py, right? Now, this should look somewhat familiar, right? Especially if you've used something like random, right? The random uh, module is usually imported in a very similar fashion, right? And we typically have used the most common one was randint, right? Random integer is typically the function we like to use for random. That's a built-in Python module that we have access to, right? That comes already made and imported, or not imported. It comes downloaded whenever we install Python into our computer. We didn't create the random module. It's one of those modules that the creators of Python know people like to use often, so they created it for us for uh for ease of access, right? But that's kind of how the random module works. Somewhere in the installation of Python, there is a file very similar to the mystats.py that has the actual code that goes into generating a random number, right? And so here we are quite literally creating our own module file. And we're able to import that file and leverage the code that's within that file in itself, right? Just like you see here, import my stats. Do you have any questions, Thomas?
Nope. If we were on Java, for example, you wouldn't be able to import obviously like a Python file like this to define classes and functions for JavaScript or vice versa, right?
It's a little weird. I'm not quite sure about Python to JavaScript, but I know in Python we are able to import JSON stuff, and we will see that in real hand later.
Hmm. Okay.
I've never done it the other way around, but we are able to convert JavaScript stuff into Python and import stuff. You'll see. There's a
Okay.
built-in method for it. All right. Import specific functions or multiple. So there's two ways that we can do it, right? Um, let's say instead of trying to import the entire file, you only want to import something very specific from it, right? Uh, that my stats file, it might have more than just one function. It might have find mean, find average, a square root function, a cube function. It might have a bunch of other mathematical functions in here. Um, and that's just as a small example, right? Much more in-depth modules out there could have hundreds of lines of code within them. A multiple a series of different types of functions that do different things. So when we do import my stats, really what we're doing is we're importing the entire file into this file, right? Uh, especially if you're not familiar with the actual module itself, you don't know how much code might there be in that file. So, a good practice is specify what exactly you're trying to import from that file so you only get that item, right? And you see that here, they say from my stats, import find mean, which is different than earlier where we just said import my stats. Here we are specifying what we want to import, and we want to import the find mean function. This limits the import to just that function, so we don't get all the extra junk that might be in that module, right? Notice that this also changes how we use the function. Earlier, because we didn't specify the function find mean, we had to prefix it with the module that's belonging to, and then we end it with the function that's in that module. Where here, we didn't import all of my stats. We specify that from my stats, I'm importing find mean. So only this came in here. So we are going to call that directly. Make sense?
Yep.
Awesome. Additionally, you do have the ability to chain multiple imports, right? Let's say there's like 100 different functions in that file. You want to import a couple. It's definitely more than one, but not enough to import the entire file. You are able to chain them in this manner, like you see here, where you can say from my stats import find mode, comma, find mean, comma, find median, where you can continue importing some other functions without having to import the entire file itself. So really, modules is just a fancy term for a file, right? That you store definitions of other functions. You can kind of see it a little bit. Let's look at our Python file. Here's streaming guide. If I do import random, right? Here is that random module. I can right click it and I can go to definition and it'll open up random.py, the actual Python file where the random module is at. Right? This is the random module. It is a Python file. You can see there, it's showing me the file path of where it's located. It's in user lib Python 3.12. So it's inside of my Python installation file. That's where it's located. This was added when I installed Python. And you can see here, look how much code there is here. There is 500, 600. There's almost 1,000 lines of code, Thomas, right? So when I say import random, I am quite literally importing 1,000 lines of code. There's so many different functions in here: choice, shuffle, randint. This is the one that we use, rand range. But typically, when we're trying to use the random function to generate a random number, we don't want all these extra additional functions. We only care for random. So once again, it's important to understand how to import exactly just what you're looking for. Because you see here, you're going to get more than what you're asking for if you just import the entire module. So we should be saying from random import rand int, right?
I
Uh,
saw I saw there when you were scrolling through the random module that it was also importing a lot of different math modules. Um, if you obviously if you imported the whole random module, it would also import those math modules as well. But if you're only importing certain functions or whatever, that may or may not use any of those math things, that's a way to cut down on time and memory complexity, right? Because you're not calling on it won't automatically import those math ones.
uh, Pretty much, yeah. You're not
Okay.
going to be leveraging on the other imports, correct?
Okay.
So once again, you want to ensure that you're only importing what you would need. Additionally, I don't think I have it in the slides, but we can give aliases to what we import. Especially if you're going to be using the command of something very often. Like if you're going to be using random often, you can say something like as r, right? So when you go to use a random function, all you have to say is like something like say a random number is equal to or and then you can say 1 through 10. And this would generate a random number 1 through 10 instead of having to type out randint 1 through 10. It's giving me an error because I have an alias, but you can give it an alias, right? That way you don't have to type out the entire function. You just use the alias you gave it. So be aware you could do something like this. From random import randint as R. Give it aliases. Cool?
Yep.
Awesome. All right. Import issues. If I import the following module and run this file, I get 15Y. Okay. So here we see a code snippet where we have the main.py importing calc.py. Well, let's look at calc.py. Calc.py, it's a module. They have two functions here, a mult function and an add function. Within this function, they have, I'm sorry, not within the function. Within this module, they have the lines here on line 9 and 10. Line 9 is actually using the mult function within here, and then it's making it print out the result. Well, what happens when we import calc into main.py and run main.py? Well, you're going to see that you're going to see the print result that's happening in the other module. Let me show you exactly what I'm referring to. Uh, New file, we'll call this main.py. Mod.py. We're going to do a add function that takes num1 and num2. Return num1 plus num2. We'll say result is equal to add. We'll pass in 5 and 10. Print result. And then in my main.py, I'm going to go ahead and I'm going to import mod. And let's run it. But when I run it, I see here, I run my main.py, right? My main.py, the only code I have here is the very fact that I'm importing the mod file I created. And I'm getting 15 here. Well, what's happening is when my main.py runs, it's only going to run line 1. Well, what is line 1 doing? It is importing all of this file. So this file is going to run. It's going to read the definition of the function. It's going to get to line 5. It's going to run the function, and it's going to print it out. So even though I'm not running the mod file, because I'm importing the entirety of the mod file into my main.py, and then I run main.py, I'm going to see here that there's code here that ran even though I didn't expect it to run. I didn't want it to run. All I'm doing is importing mod. So maybe later on I can use, you know, the mod.add function here, right? And then I try to run it, and I'm like, what the heck? I know this function is supposed to give me 16, but why am I also getting 15 and 16 when I didn't print out 15 here? There's nothing here that should be giving me 15. I should only be getting 16. So it might confuse me, right? Well, that's because there's some code in the mod that is doing that. Does that make sense?
Yeah.
So you want to be careful with that. And how do we do that? Well, it's by using the if name is equal to main function here. So by default, when you import a module, it's going to run everything from top to bottom. right? So what you might see when people are creating Python files that are going to be ran by either importing or by running them individually, you might see people create a main function, right? The main function uh, is done so in the event there is code in that file that you want for it to run when being used as a script, it'll run, but it shouldn't run when being imported as a module. So let me show you how that works. In my mod file, let's say I do want to run this, but only when I run mod.py individually, not when it's being imported. What we'll do is we can define a main function where we're going to put this within, and it's only going to run when we run the main function. So we can say something like if name is equal to main, we run main. Now, I know it looks a little confusing right now. I'll show you what I mean. Now, when I run my main.py file that's importing mod, notice I don't get that 15. But when I run mod.py, I'll get the 15 back. Why is this happening? Well, let's see if we can do this. Print. I'm in main.py, right? I am printing out because you're probably wondering, well, Roger, what the heck is this? What is underscore name underscore underscore? Like, what does it mean? And what does it mean? Why are we comparing it to this string underscore underscore main underscore underscore? Well, let's print out underscore underscore name and see what it gives us. When I ran this, it's gonna print out main, right? I can do that over here as well. Print name. It prints out the main when I run it. But when I do it in the main.py, it shows up as mod, right? When I run the import mod file and I run the main.py is going to try to import all of mod. Mod at line 10 is going to print out whatever underscore underscore name is. And now it's saying that it's called mod. So the double under name, double under is referring to itself. Here, when I run mod.py individually as a standalone file, I'm running it as a script, right? It's being ran as a standalone file. So what is the name of this file? Well, its name is going to be called main. This is the main file that's running, right? The double underscore main double underscore. So that's what this line 10 is checking is, hey, the file that's running, is it the file I'm being called in, or am I being called into a different file? Well, because I'm running this individually as a standalone file, name is going to equal to main because the file that's running is main. But when mod is being ran as an import, it doesn't run that main file because it's no longer called main. It takes the identity of whatever that file name was given. Does that make sense, Thomas?
I think so. Can we try it with a different type of example? Change it up? See if I understand it.
Let's see.
Because I guess where I'm getting confused is like I understand that you're calling the add function in the main function, but I guess I'm wondering is like why would the add function need to go in the main function?
Um, I'm trying to see a good way to show you. Um, can you hear my niece in the background? No.
No.
Okay, good. All right, so notice the main function, it only has one thing right now. It's saying I am being ran as a script, right? I am being ran as an independent module. My name is main. This is only being shown when I run mod.py on its own, right? Because what's happening is when I run this file, sure, I have a definition for add. It won't do anything. I have a definition for the main function, but we know that main well functions in general they need to be called. So we add an if statement that's going to call the main function only if this keyword matches this string. Well, this keyword is referring to the file itself. It's like saying this, right? Like this or self. If this is equal to the string of main, then I want to run the main function. So when does it equal to this string here? When it's being ran individually. When a file is ran, that file that's being ran, it gets a nickname. That nickname is this string right here. Double underscore main double underscore. Right? It gets this nickname. Now, if I run main.py, who's gonna get that double underscore name? Is it mod or main?
Wouldn't it be main?
It will be main.py because I'm running this file. This is the file that's being ran, not mod, but main.py. I'm running this one individually. I mean, maybe the name is throwing you off. Let's go ahead and create math homework.py. Import mod. Okay, if I run math homework.py, which what file is the file that gets the nickname of underscore main underscore? Well, it's going to be the math homework file because this is the
Mhm.
file that's being ran standalone individually. So because this one, the one that I'm running, math homework.py, is being ran as a script, when it imports mod is going to read this line right here and it's going to check if it's main or not. Well, this file is not main no more because it's not being ran individually. It's being ran as a module. It's being imported, but the way that mod is being ran isn't as a script. It's being ran as an imported module. Does that make sense?
Yeah, okay. So just to double check, the first one, the underscore name, that's the nickname one in mod. The
No.
the underscore name, that's not the nickname.
Yeah, so this nickname is given when it's being ran as a standalone file, right? Let me show
Mhm.
you. Print look, I'm gonna make sure that when I run math homework, it's going to import mod, and mod is going to run line 8. It's not gonna run this one because this is gonna be false, but it's gonna run line 8 for sure because that's not inside of a function. And look what it prints out when I try to print out whatever that name is. Print. Uh, I am math homework, comma name. I am mod.py, comma name. When I run math homework right now, I get two print statements. Both of them, I made them print out a string and then the variable of underscore underscore name underscore underscore. Notice what the name is for mod and what the name is for the math homework. Do you see it?
Okay. Yeah.
Why is math homework displaying to me main, but mod is displaying to me the keyword of mod, right? Well, because when a file is being imported, the nickname it's going to get is the name of the file. The file that's being ran is going to get a nickname of main. Make sense?
It makes sense.
Now, let's see what happens when I run mod.py on its own. Notice here, it's going to run line 8, which is I am mod.py. Notice how now this change is no longer mod. It's saying that it's main, right? And then it gets to line 10, is going to read this if else statement. And because
Okay.
it's called
Okay.
main, it'll run the main function. Make sense?
Okay. Yeah, I see what you mean by it's synonymous with this now. I see how it is now. Okay, that makes more sense.
Right. So the name of the whatever this name is going to depend on how it's being ran. Is it being ran as the main file or is it being ran as an import? So yes, you're correct, Thomas. I know it can get a little confusing. So this will always take a little while to kind of explain. But that's what keeps it from running on its own when being imported. So you've probably seen this before. You probably have seen people, especially if you've seen YouTubers code in Python and you're trying to learn something, you might see them make like a script, or some kind of code and they add that little piece at the very end. You're like, why the hell? What does that even mean? That's what they're doing. So if the file is imported, name will equal the name of the module and the file won't be executed, right? If the file is run as a script, then name will equal main. So the script will run line 10 and 11, which we just saw in real time. All right. So the first exercise for today is going to be basic stats.py. Let's go ahead and see it real quick. Basic stats.py. So by the way, all these are going to be a object-oriented programming, right? The only difference is now we're introducing using the different modules. This is a fairly easy one. Uh, so I don't expect you to have that many issues. I'm sure you've probably used one of these imports already. Uh, so let's give it a try. Let me go ahead and stop the recording real quick. Good stuff. You want to showcase real quick, just see what your answers were,
Sure.
um, for the camera for anybody, and then we can move on with the assignments.
Sure. All right. Sharon.
Yes, sir. Oh,
Okay.
that was way too easy.
So imported it using an alias because statistics is way too long. Created a class, initialized it with the student name and grade, set them to themselves. Got a getter for the grade, and did a function outside of the class like it wanted. Created a list because when I clicked on this and I looked at, oh, hold on, disappeared on me. I'm trying to show you what I used because I didn't quite know how the modules were going to work because it just told me to use the mean, median, and mode. So I just clicked on the link there for the module, but I could have also did what you showed earlier and right clicked and got the definition. But
Hmm.
I just looked at and how it would function to see if I had to do each number individually or if it would work on a list or anything like that. So saying that it would work on a list for all three, I just simply created a grades as an empty list, iterated through, used the getter, and appended all the grades to an empty list, and then returned the module function call for each one in a tuple like it wanted, and got that.
Nice. Yeah, pretty straightforward. Awesome. Good stuff. All right. Let's go ahead and move on. Okay. Share screen. All right. The next topic we're going to talk about today is going to be exception handling, right? So up to this point, you've probably already noticed, you know, you've been coding for a while, so you've noticed some issues with code, especially when you run into certain problems. One of the very first problems that you encounter as a beginner coder, which everyone starts off with, is going to be your syntax error, right? This is the most common one because you're not used to coding in this language, right? So you forget the grammar or structure of how to write the programming language. So syntax error is probably one of the errors that you saw the most when you first started off. This was usually something like forgetting a colon, a misspelled variable that you're trying to call in a way or a function or wrong indentation. These are syntax errors that you might encounter. Um, and then you have something like exceptions, right? All the other errors that stop your program and print out an error message, right? And the issue with that is that first line right there, the fact that it stops your program and prints out an error message. So this is very problematic. Now, sometimes there's errors that you might be expecting, right? There should be sometimes the possibility that what if something does mess up? Well, I would like for it to mess up, but not stop my code because what if it is a probability of something happening, but it should still continue moving along with the rest of the code. Well, that's what brings us to the next part of today's lecture, which is going to be handling those exceptions. How do we do exception handling? So our code doesn't just stop the moment it runs into a 1 foot wall. Um, it will handle it in the way that we dictate and then able to continue with the code, right? Um, so let's let's see how that works, right? So here, a way that we can handle errors is by what we call a try and except block, right? This is really similar to an if else, right? It's pretty much an if else statement, but it's a little bit more powerful. So here we have on line one a variable called numerator, or they're taking the 10 and they're doing it to the power of 3, right? 10 to the power of 3. They have the denominator, and the denominator is going to be the result of the input from the user, right? They ask the user to enter a number for the denominator. They then convert it into an integer and to assign to the variable called denominator. Now, uh, the next part of this code is added to a try and except block, right? That's because there's a possibility that maybe a user could give us some kind of input that isn't acceptable, right? that could cause an error in our code. What kind of error could that be? Well, one of the errors that you probably haven't seen, because you probably haven't encountered it yet, or been in a situation where you've encountered it, is the zero division error, right? That's when you try to divide something by zero, right? So we know that is a possibility. So we use the try and accept block to ensure that we're able to capture that possibility. Now, the way this works is you start off with the try block, where you're going to try to do exactly what you want to do uh, for it to work as intended, right? So they do that on line 5. They create a variable called results, where they take the numerator and divide it by the denominator and convert this into a float. Finally, they print the result. Now, the issue here that might happen or where it might happen will be line 5. When they try to divide numerator divided by the denominator, something could go wrong, and we've anticipated this, which is why we put this bad boy in a try and accept block. So in the accept block, we say accept zero division error. So we're going to try line 5 through 6, except in the event we get zero division error. Is pretty much how this is being read. Does that make sense, Thomas?
It does. I noticed that the zero division error is blue, just like float. So is that like a predefined error
That
message?
that is correct. This is a
Oh,
built-in error that can be encountered. So you are able to catch errors that are built in the same way that you see here. You can say try this or accept if you have this error. So yes, it is a built-in error. So we're saying accept zero division error, and line 8 will only run if we catch a zero division error. Could there be other errors? Yes. I want you to be aware of that. There could be other errors that could happen. If a different error that is not the zero division error is appears, then line 8 will not run. So be aware of that. This try next step block is only going to capture this specific error. So what happens if, let's say, this works, but there's some other error in the rest of my code? Well, if the try block fails and it wasn't a zero division error, then you'll never see this message. It just won't work. And you'll see what I mean in a little bit. But pretty much, once again, the way this works is we try first whatever is within the try block. If it fails, we resort to the accept block that's going to capture the zero division error and to tell us division by zero is undefined. Now, we have built-in errors, but sometimes we have very unique situations where we want to be able to capture something, but it isn't built into Python, right? And this is what we call a user-defined exception, right? Uh, for example, there is no error for an imaginary number, right? So, can you hear my niece yelling in the background?
no, not at all. You
Oh,
have some pretty decent noise canceling.
good. Jesus Christ. All right. Uh, so most of the time you don't need to raise a built-in exception, right? This is actually uh very unique, right? You don't always find yourself in a situation like this where you have to create a custom error, right? But if you did, we are able to create a custom error by leveraging the exception class, right? We create an exception. So an exception is a class of error, right? All the errors that you have they have some kind of they derive from the exception. So you're able to create your own custom class and call it what you want, and you're able to inherit from other classes. So we haven't talked about inheritance, um, unfortunately. When you get into the immersive program, you'll talk a lot more about these different pillars like inheritance, polymorphism. the different pillars of object-oriented programming. But one thing that to ensure that we can move forward with this class is you are able to inherit in a class, right? You'll see that more when we talk about working um, with our Pi game that we're going to make later this week. You'll see that working actually a little bit better. But an exception is an error class. So it has certain functionality and traits, right? Have you ever seen shows like uh let's see, like Invincible? Have you seen Invincible? Maybe not the best show to bring up here, but have you seen Invincible, Thomas?
I don't think so. Is that the animated one or?
Yeah, it's the animated one. The one with Omni-Man. Or
Oh, yes, yes.
right. So, well, really, any superhero show will work, but pretty much it's fairly common that if superheroes have babies, chances are their kids are going to have powers, right? Think of the Incredibles, right? Chances are they're typically going to inherit the powers or abilities of their parents, right? Uh, so if the parent can fly and have super strength, you're able to inherit those traits, and whoever inherits it is able to use the same functionality that their parent class can do, right? So we can mimic that kind of functionality here. So exception is a built-in class that comes with Python, and we're inheriting from the exception class so we can have the same functionality of the other errors. So we can create our own custom error, right? Uh, which is why you also see here pass. They're passing any code here. They're not adding any additional functionality, right? You could customize this further and change stuff or override certain traits or properties. But for this to work, really, you don't need to do anything else besides just inherit from exception, and you can just put pass, and it'll work just like any other error. So that's kind of how they're doing it here. You can get a much more in-depth class on this at a different time if you wanted to or look more into it. But this is a way of how you can create a custom error. So this error is the imaginary number error. They're going to ask the user to enter a positive number, right? And then they're going to convert it to an integer. And now they're doing an if-else check, right? Notice they're saying if user input is greater or equal to 0, then they should be able to do, I believe this is the square root here, due to the power of zero point 0.5. But what happens if they give you an integer that is not positive? That's negative, right? That's pretty much an imaginary number. Well, we're able to raise that error ourselves. So what happens is if the number is not greater than 0, greater or equal to 0, then we are forcing our console to raise that error, right? So notice here on line 10, we ourselves we force an error into our console, right? We forced our error our code to stop and give us this error. Right, so you're able to create your own custom errors, and you're even able to raise the errors yourself. Right? Any questions?
So raise is basically just the another like when you create your own exception, it's raise is basically using except.
No. Raise is it's a trigger. You're pretty much like, hey, activate this error, make this, or you're raising the alarm. Pretty much is the way that I like to think of it. Right? It raises the error and it stops your code. So the except block, it's a little misleading because they use an if else block here, but really you could have used a try and except block as well, and it would have worked just as fine.
Okay, so you can still use raise in an accept block as
Yeah.
well.
So I
Oh,
mean,
okay.
right, we raise an error here in the else statement, but you could place this code in a function and use a try and except block as well, right? But so I know it's a little misleading when this was created, but really don't focus on the if else. What's important here is the fact that we are able to create a custom error and we're able to raise the errors ourselves in the middle of our code, so it stops the code and prints it out in the console. Make sense?
Yeah.
Awesome. All right. So you probably will need a little help on this, so I'll let you try it out. But try out the out of range.py. It's going to make you create your own custom error. Really, just do it exactly how you saw on the slides. Um, you're going to create your own custom out of range error, which really all you have to do is just put pass in there. At time is 6:46. Let's go ahead and come back at 6:56. And if you couldn't solve it, then I'll help you out. I'm going to pause the recording.
Sounds good.
All right, you want to showcase?
Sure. Give me one sec. Let me see back into this thing. Okay. Share screen. Okay, cool. Am I up?
Yes, sir.
Okay, cool. Uh, so class made the exception with the inheritance. Uh, did the name the number, asking for an integer, and converted. Um, did the if elifs and then raised the error and then created a function to run it that did the try and then the accept and then ran it. So enter an integer, one out of range, calls the error. Then we do one with n, returns the right value.
Nice. Awesome. Good job. Very straightforward. One thing I want to note for everyone watching this and for you too, Thomas, the try block, very, very powerful stuff. All right, very powerful stuff. I love it. It's great. It looks slick compared to an if else block. Now, there is a drawback to the try block. You do not want to overload it with a lot of logic in there. Right? Your try block should try like to try to do one or two things like tops, right? Give or take, right? It depends what the context of the situation. But what I'm trying to get at is if there's multiple points in a try block where something can go wrong, you have to make sure that you take that into consideration or don't use the try block, right? Uh, because it can be very difficult to kind of debug to figure out where the issue is going, especially when you're trying. If you don't usually try an accept block right, you're not catching the specific errors that's is raising. Um, and if you have like 10, 15 lines of code inside of a try block, any one of those lines could have broken, and now you would have to kind of go back and check every single part to see how far it worked. Because the moment that any part of that try block fails, it'll immediately resort to an accept block, right? So be aware of that. Um, so it could be a double-edged sword if you have a lot of logic in there. Does that make sense?
Yeah.
It,
Side question, is
yes.
there like a just like if else statements, is there a if elif version of the try except?
Try and then you do accept. And then I've used multiple accepts like back to back to see which accept it's gonna resort to. So
Gotcha.
yeah,
Okay.
you can chain them. I've done it before. Um, so but yes, in a sense, yes. All right. Last thing we're going to cover for today. This is going to be very brief. Unit testing. Right. Unit testing. And one of the reasons why I cover it in this course is um, when you first get to the program, you're going to be administered one of the hardest tests that you'll have in the entire course within the first 2 weeks. I don't remember, it might have gone through different changes, but there's like on average about 25 different tests that you're going to have to run and pass on your life technical assessment. Unit tests can be very confusing to read if you've never read unit tests before, and it can throw you off. Um, you'll get instructions to how to code your assessment, and then you'll code it, it'll work, but a unit test will try to test your code to work in a certain manner, right? So we know there's different ways to skin a cat. That's definitely true in coding. But if you're not doing it to how the unit test wants you to do it, it will be marked as incorrect and your unit test will fail. So it's important that we're able to understand how unit tests are created, so you can read them and understand them once you get into the immersive program. But additionally, unit tests is something that you're going to have to do and work with when you get into the field as well, because there is such thing as test-driven development, where you build the unit test first and then you build off the unit tests. Uh, Not a great way of doing things, but it's a common way of doing things. But just be aware of that. So the unit test uses what we call assertions. Um, they're pretty straightforward if you read how these methods are called, right? For example, the first one, assert equal, is going to take two arguments, A or B, and it's going to assert whether these are equal or not, right? Whether A and B are equal. And then you can kind of guess what the next one is, assert not equal. It's going to check if A or B are not equal. And so on and so forth, right? Assert true or false. Assert is or is not. And not in. Almost equal or not equal. That was a little bit more unique. That will compare floats and check to like accuracy to a decimal places. So that was a little interesting. All right. For the unit tests that you'll be using, if I remember correctly, you should still be using unit tests from Python for your first assessment. Unit test is a module that you will import. You can kind of see here in the code snippet, you have import unit tests, right? So the first thing you do is you have to create a test file, and you're going to import the unit test along with the files and functions you want to test, right? So here we have the function called list max that we're trying to test out. So that's what we're importing into the unit test file, right? Which is being saved into a main.py file. But we're trying to do it within this main.py. We're importing the unit test on line 1. And on line 2, we're saying from list funcs, import list max. The next step will be to create a class that inherits, right? A class that inherits from unit test dot test case, right? We haven't talked too much about inheritance yet, but you can see here we call the on standby. Sorry, my niece crawling underneath my desk. All right. But so on line 4, we create this class called test list max, right? And for this to be able to work as a unit test, we have to inherit from the unit test dot test case, right? Written exactly how you see this. This is case sensitive, right? Whatever you call the class itself doesn't really matter. It can be whatever you want. Next is we create the individual tests themselves. So look at the first one. We do test 1 because this is in a class, right? It has to start off with self. So we pass in self. And this class, they add some comments here. It's going to test all lists of test a list of all positive values. So they create a list here with positive values, and they're going to use the function they created list max with that fake data they just created. Now they're going to call the assert equal function, and they're going to pass in the result that comes back from the function they're trying to test and what the correct answer should be. So if this function worked correctly, this should ideally return 100, right? So when you run this test, it's going to compare the 100 against your function and how it works with this dummy data, right? Do you see how this works so far?
I think so. The assert equal was pulled from the import unit test, right?
Yes.
Okay.
We have access to assert equal because it was inherited from the unit test. So
Was it
we imported unit tests.
right?
This gave us access to this class here that we inherited from, right?
Gotcha. Okay, so the assert equal was pulled from dot test case.
Right. So remember, like I
Okay.
told you,
Okay.
when a class can inherit certain properties or functions of other classes, right?
Hmm.
So that's why when we create this class called test list max and we inherit it from another class called unit test case, or really specifically test case, right? Because we're calling the module
Hmm.
and we're inheriting from the test case class.
Okay.
We're inheriting from this class, and this class comes with some built-in stuff like you see here, assert equal being one of them. So that's why we can say self dot assert equal. We say self because this is within the test list max, and it has this function now because it inherited from the test case. Make sense?
Makes sense.
Yeah. So although
Is
we didn't create it ourselves, I know that it has it because I inherited from it.
now stuff like this, like unit test, for example, that's something that was made. That's not a built-in, is it? Or is that actually a built-in Python?
This is built into Python. We installed it, right? It's kind of like the random module.
Oh, okay, gotcha. And okay, I was just trying to determine because stuff like that, you wouldn't see like the privatized thing, so we wouldn't need the double underscore for that.
Yeah, no, don't worry about that. We're
Okay,
not doing
okay,
that here. Yeah,
okay.
this is a very unique situation. All right. Now, you also need to ensure that you do the if name underscore name is equal to main, and then you're going to do unit test dot main, right? You're going to run this specific line right here, right? So, there's no better way than to try this out yourself. So I'm gonna let you try it out, but this is kind of what it looks like, right? Let's say you have 5 test cases. When you run your test case or your test file, if all the tests pass, you should see something like this. You see each dot here represent a successful test that ran. And then if it failed, that'll be represented by an F, as you see here on the slide below. The second dot here, instead of a dot, it's an F. So that was the second test case. It even tells me here, fail test number 2. And it tells you the error and what line it failed and the assertion. 1700 did not equal 170. Right? It tells me it ran 5 tests in so many seconds, it failed 1. Sometimes you might have an error. Maybe you coded something wrong. And instead of an F or a dot, you'll see an E, I think, if I remember correctly. So be aware of that. Try to create a unit test for multiply.py. I'm going to pull up the slides so you can see it as a reference. Let me go ahead and pause the recording. So I always, to be complete transparent with you, I don't memorize every single import. No one memorizes every single import and command of all these things. So don't feel like you are required to. But let's go ahead. I'm gonna create a new file here. I'm gonna call this test.py. Um, let's create the multiple. So let me go ahead and copy and paste this into my multiply.py. Let's generate the code for it. Um, word rep. We can call this together. We're gonna write a
'Cause
function. What's up, Thomas?
oh yeah, I was just saying because I imported the unit test and then I clicked on the definition of it,
Uh-huh.
but it didn't really give me much information as to like what I could call from there. Like on the slide, it was like from list funcs, import something. I didn't see like list funcs as an available option to
List
uh
funcs is from the function they created. It's a custom function, right? So watch me,
oh, gotcha.
right? So here in write function name multiply three numbers. So let's go ahead and define that. Multiply three numbers. So this is the scenario here is I'm creating some kind of function or program at my company for everybody else to use, right? Now here in this scenario, this is a very simple function, right? But you might be creating some very complex code that's going to do some crazy stuff, right? This is to take three parameters and multiply them together. So we'll say num1, num2, num3, and then returns the result. So they should return num1 times num2 times num3, right? Very simple function. But in the real world, this might be very complex. Now we're gonna write a test file for that function that contains at least five tests. I'm not gonna do five. I'll do one or two so you can see how it works. Um, so we can test this function out, right? So although I feel confident that my function works, there are so many things that could go wrong with code. So many things that could go wrong, which is why we create tests to test out every possible scenario. So we create a test file, and I'm going to go ahead and import unit test, which is a class that I'm going to be inheriting from. And then I'm going to create my class for this unit test. I'm going to say test multiply function. And I'm going to inherit from unit test dot test case, as I mentioned. All right, I believe that was correct. Let me sure. Yes, unit test dot test case. Right. So unit test is the module that has the test case class. I want to create a custom test case class. So I got to inherit from it. So I call the module unit test and I specify that I want to inherit the test case class into test multiply function. Next, I can define my methods. I'll define test1 because it's a class I required so. Now, if I want to test out this function, I need to have access to this function. So I'm going to import it. I'm going to say from multiply imports, what did I call it? Multiply three numbers. Multiply three numbers. Right? If I'm going to test this function out, I need to have access to it. Therefore, I need to import it. Make sense? So
Okay.
I'm going to create three random numbers. I'm going to say num1 is equal to 2, and num2 is equal to 5, and num3 is equal to 10. So 2 times 5 is 10, times 10 is 100. I know the correct answer should be 100, right? So let's go ahead and see. I'm going to say
Wow.
result is equal to, and then I'm going to leverage that function I created to see how it works. I'm going to pass in num1, num2, and num3 as arguments. And then I'm going to use an assertion to assert the result against the correct answer. So I know that this function needs to be able to multiply three numbers together and return to me the result. So here's my three numbers, 2, 5, and 10. 2 times 5 is 10. 10 times 10 is 100. So I know the correct answer, if I were to pass it into this function, it needs to be 100 because I know that's the correct answer, which is why I am using the function. I'm grabbing what's going to come back from it, and I'm going to check if it's equal to 100 to see if it's giving me the correct answer. Make sense so far, Thomas?
I think so, because some of your stuff's lighting up. Mine. Oh, okay, never mind. Okay, I see my error. Makes sense.
Let's give it a try. I'm going to go ahead and run this. And there you have it. I run this file, test.py. I see here's that dot to represent that one test case. It says I ran one test in 0.006 seconds, and I got an okay. I didn't get any errors, nothing messed up. Now, let's say hypothetically, whoever created this function, they screwed up. They they instead of multiplying that third number, they added it. Jesus. Okay, there we go. Right. They screwed up this function. They did not do what they should have done right. Right. The work that they should have done. They go ahead and they try to test out that function and they get an error. What the heck? What's going on with my code? Like I thought I did the function right. Well, let me see. Let's see what the test case says. It says that I failed test case number 1. It says that I failed the assert equal. The result did not equal 100. Result was 20. Like, why did it give me 20? I can come back to the test case. I see here that it tried to reuse my multiply three numbers function. Apparently, it returned 20, and it's supposed to be 100. So I'm like, well, that's weird. It should give me 100. Why is this returning to me 20? Does that make sense? So
Mm.
you create a function and then you test it with every possible scenario. What happens if you try it with like something that's not equal or negative numbers or decimals? How should it work? You create tests to test out your code. Does that make sense?
It does. So what it was actually asking for, like we could keep using the assert equal, but it was realistically just wanting us to play with like the numbers and stuff like that, right? Not just changing like assert equal.
Right, right.
Okay,
That's a good.
okay.
So we can make multiple test cases here. This is 2. This could be 3, and then here we can change these numbers. We can pass it something like, let's try out with decimal values. For one of these test cases, let's do negative values, right? And make sure you actually do the math so you can try to see what the real answer is. I don't know. This would be negative 100, right?
Yeah.
10 times negative 10 should be negative 100. 2 times zero point 0.5 should be 1 time. This should give you 10, I think. I
Hmm.
think. And I failed a 1. Oh, that's right, because I messed it up on purpose. There we go.
So, Roger, what's the point of running tests if you already know the answer?
Oh,
Oh, just to check if
I
the
know the answer right now, right? But it's obviously you don't see a big help here because it's such a simple function, right?
right.
It's such a simple
Uh-huh.
function. You have very limited data to work with, right? But let's say you have um you know hundreds of thousands of data out there of multiple different possible results that you might get back when you try to search up for something. Um, or let's say you want to test out the how your login or sign up button works on your application. You want to make sure that it is successfully signing up only people that pass in a valid email address. So you might want to create different test cases that check for different variations of email addresses. What if they try to add like, nothing but spaces in the email address, or like a more exceed the character count. Maybe add some kind of weird code in there, or some kind of domaining that doesn't make sense or doesn't exist. Different stuff like that that you could do. Uh, every possible scenario that you could test against, right? It allows you to try out your code to make sure that it's taking care of every possible scenario that could happen. Right. In this case, it's very simple. These are just numbers. We're just testing negatives, positive, decimals. But for more complex code, that there could be a lot of stuff that could go wrong. This could be a good way of doing it. Instead of running your website and then you don't want to find out that your website doesn't work when it's deployed. You want to find it out here. Does that make sense?
Yeah.
Is this how
Additionally,
like
what's up?
oh, I was just gonna say, is this how like CoderByte checks to make sure like you have the right stuff?
I was thinking the
Yes,
same thing.
yes, it's very similar to this.
Hmm, okay.
It's similar to something like this. Correct. Do I have any questions? Well,
Don't think so.
I'm gonna let you guys try this. This is kind of so you don't have to spend too much time on this, but definitely create 2 to 5 different test cases using other assertions. I use assert equal, but try out the assert not equal. Is the false or the Boolean ones is in or is not in. Try those out. But don't spend too much time on it. What I really want you guys to focus with is going to be what I'm going to finish off today with, which is going to be the final or the hardest exercise that we'll have for this course, which is going to be eliminate stand.py. So, eliminate stand.py will probably take you, I don't know, I've had other students take like 2 hours, 3 hours to do this, and they still struggled. Thomas, you've been killing it, so I don't think you should have a big issue. But eliminate stand.py, Thomas, if you did the streaming guide, it's going to be similar to that. You're pretty much, you're replicating a stand and selling lemonade or different products, right, to customers and keeping a log record of your sales. So I want you to try this out. Tomorrow, if you show up and it's not complete, that's fine. We'll probably spend an hour on this one because this is a big one. Probably tomorrow, we might even spend all day doing lemonade stand pie. But you could definitely start it today and get a heads up on it. All right.
Sounds good.
Cool.
Let me see. We have, yeah, we'll probably spend. So this is a very important one, reading and writing files. We'll see how we go tomorrow with lemonade stand up high. But yeah, it's a doozy one. Try it out. Alex, you focus on catching up on those 2 videos.
hmm
Let me go and pause the recording.